Okay, so now we're going to talk about vertical asymptotes. So remember when we have f of x equals 1 over x, our reciprocal function, we would have a vertical asymptote at the y-axis, right? So x equals 0 because you can't define the function when x equals 0. So we're looking for those places where where the function is not defined. So when does the denominator equal 0? So we did that, when we were looking for the domain. We're going to do the same thing. Now in this problem here, you'll notice that it's a negative x squared. I would probably factor that out. So I would write mine like this. Put it in standard form. And I'd take out the negative 1, and that would make it x squared plus x minus 2. I would just do that out of habit. Now that negative 1, it doesn't change anything. The negative 1 could be put in front of the expression, and that would be fine. And it allows me to factor the denominator. So, let's see. I'll go over here to factor it. So I get 2x squared plus 5. I'm not going to worry about the negative 1. It can just be there. And then this trinomial is going to factor into x plus 2 and x minus 1. You don't have to do that. You could factor it the way it was, but for me it's just easier to factor that way. Okay, so I can see that I don't want x to be negative 2 and I don't want x to be 1. And so those are the vertical asymptotes right there. I didn't put doesn't equal, but maybe I knew what was coming. But those are equations for the vertical asymptotes. That's where it's not defined, okay? So when you're graphing this, which toward the end we're going to be doing that, you would have like 1, negative 2. Okay, you'd have a vertical asymptote there, and then you'd have at 1, you'd have another vertical asymptote there, okay? Vertical asymptotes, you can't cross when you're graphing those. So I'll just throw that in now. I'll probably say it a bunch of times later too. But anyway, those equations are the equations for the vertical asymptotes.